Hello guys, welcome to our channel Technogan Max. Today we are going to discuss noise analysis in mechanical gearbox. So we are going to discuss in 6 steps. So the first step is to get familiarized with the equipment. So what is the equipment? So it's a mechanical gearbox, single reduction, and this is pinion which is having 30 teeth, and this is a gear which is having 121 teeth. There are upper and lower housings, bearings are there, input shaft, output shaft is there, and vibration sensor is there mounted on the cover. So this is the general arrangement, and it is filled with the oil. So once we know about the equipment, then we move on to the step 2. So we have to determine the important speeds and frequency. The input shaft is rotating at 1450 rpm, and if the rotation, to find the rotation per second, we have to divide by 60, so it will come around 24.2 rotations per second. So it also called as 24.2 hertz, or 1 event, or 1 times speed of the shaft. The input pinion is having 30 teeth, so 30 teeth plus 1 rotation of shaft is 30 events. So 2 shaft rotation is equal to 30 into 260 events. So total events per second is 30 number of teeth into 24.2 rotation per second, that is 726 events per second. We move on to the next page. So the gear mesh frequency, the number you should know how to analyze the vibration in any gear arrangement. So pinion gear is having 30 teeth, turning at 24.2 cycles per second or hertz. So gear mesh frequency is 726 hertz. Any gear mated with it will have the gear mesh frequency of 726 hertz. Mating gear in this case has 121 teeth. So divide gear mesh frequency by 121, you will get 6 hertz. So output shaft must be turning at the approximately at 6 rotation per second, that is 6 hertz. Gear ratio is 121 by 30, that is 4. So step 3 is, here we get the plot from the sensor. So in this plot, if you see, there are few spikes and there are regular spikes. So the x-axis is frequency in hertz, and y-axis it's inches per second. That is the intensity of the vibration. So if you see the first spike, that is this one, so it is having 0.02 inch per second magnitude, which means it is for the 24.2 hertz. So it is one time frequency, and it should not be a problem because it is very less value. So this is the one time frequency which is generated by a pinion. So step number 4. In the step number 4, look for the next peak, that is signature vibration patterns. So greater amplitude is at gear mesh frequency. So the gear frequency here, it is observed as 726.1, closely matches with gear mesh frequency of 726. So amplitude is 0.1 inch per second, which is in the moderate range and not be a serious problem. So, and these are the side bands which we will be discussing further in step 5. So we move on to the step 5. So the step 5 are the side bands. As I said, that side bands typically of gear mesh signature identifies other vibrations present, and side bands are the product of modulation vibration from elsewhere transmitted or even amplified by the strong gear mesh acts as a carrier frequency. So there are 2 causes of the side bands. One is from the outside the external environment, there are noise, and also the strong gear mesh frequency acts as a carrier for these side bands. So side bands provides visual representation of low level vibrations carried by strong vibrations. Possible patterns are regular and random. So these are the regular vibrations, and these are the random vibrations. So there is no particular pattern. So we move on to step number 6. So the regular vibrations, if we analyze and if we see the delta for these high peak, so it is around 24. So if you see the delta frequency, so it is around for the 24.5 hertz, which is the shaft speed. So and divide the gear mesh frequency by the delta frequency. So it is 24.2 hertz, which is 30. This is equal to number of teeth on pinion. So this difference is matches with the one time frequency of the shaft. Now what about random plot? So sidebands randomly spaced, it is like this. So it is randomly spaced and there is no consistency. So this signature on the noise floors and family of the vibration around gear 84.5 hertz, which is the shaft speed. So and divide the gear mesh frequency by the delta frequency. So it is 24.2 hertz, which is 30. This is equal to number of teeth on pinion. So this difference is matches with the one time frequency of the shaft. Now what about random plot? So sidebands randomly spaced, it is like this. So it is randomly spaced and there is no consistency. So this signature on the noise floors and family of the vibration around gear mesh frequency, they are not clearly have defined peaks. These vibration patterns are very less common and more difficult to interpret. So how to do that if you have the random? So reasons for random vibrations are gear are extremely loose and gear teeth are misaligned, then gears are vibrating randomly, gear lubrication is failing, and we see rub marks on the gears. You will find more gear mesh vibrations of the misalignment in high. When the misalignment is high, it will generate harmonics and subharmonics of the one time. Traveling low vibration frequency coming from outside or meshing the side bands, are masking the side bands, and create the illusion of the random vibration. So the external frequencies are masking the side bands frequency and create the illusion of the random vibrations. So to how to solve this problem? So we can have time domain plot, can give the correct answer. So we have these values, and if you see the difference between the if you measure from highest amplitude peak of one pulse to the highest amplitude peak of the next pulse, you will get the difference of 41 milliseconds, which is if you convert to frequency, it will be 1 by 0.041, so 24.39 hertz. It found that frequency difference of 24.3 hertz is equal to one time speed of input shaft, that is 24.2 hertz. So it is sure that it is from the vibrations of coming from the pinion gear. Suspect presence of minor but developing problem, assess equipment and recommend corrective actions. So what are the step number 6 is recommendation. So recommendations are problem is developing with pinion gear, vibrations levels are moderate and are within limit, no need to shut down the equipment, continue monitoring is required, during next shutdown inspect the gear wear and evaluate the lubrication quality, additional data to be collected before restart. So these are the 6 steps to be followed before analyzing any noise issue. I hope you liked the video, and please share your views and thoughts in the comment box. We'll be coming up with such technical videos in coming days. So thank you for watching.